Hi, everyone, and welcome to another episode of the Go STEM Show. Go is Gelfin Outreach, of course. My name is Pam Piskridge. I'm the Program Director for Gelfin Outreach. And the URL, the website that you see on the screen is where you're going to be able to view this episode, or we're viewing this episode and future episodes. You can even look at past episodes as well. On that website, we'll list information about upcoming guests so that you can ask a specific question to someone that's going to be on the next show, or just a general question for us to use on any show. And then the questions are sent to Gelfin Center at andrew.cmu.edu. And we may be able to get your question on a future show. On today's show, we are featuring the Jen Lab. Dr. Cody Jen researches chemical reactions that form and grow particles in the atmosphere. The lab focuses on designing and building instruments to measure those particles. And on a personal note, I just want to thank Cody. Cody has been with the Gelfin Center since she joined CMU as an associate professor. She has taught our Saturday classes. She's taught our summer program. She's done professional development for us. And now I guess this is the full circle. She's doing remote learning with us. So that said, Cody, come on and say hello to the group.
Like Tim said, my name is Cody Jen. I joined in 2018, and Pam, you gave me a promotion. You said associate professor, and I'll gladly take it, but I'm still an assistant professor.
Sorry.
It's totally okay. I'll gladly take the promotion. So as Pam was mentioning, our lab group focuses on air pollution and climate. And so we have a whole bunch of new faces in the Gen Lab group, and you'll meet all of them. But I come from a background of engineering. So I've studied chemical engineering and mechanical engineering at Minnesota. And then I went to environmental science at UC Berkeley. So I kind of lived all around the country. But primarily what I'm interested in is what is inside the air we breathe. We spend a lot of time breathing. If you think about it, we've been breathing our entire life. So it really matters to me what I put into my body. And I kind of want to know what those particles are made out of, what else, where are these particles coming from. So big focus of our research, and you'll hear about from all the students, is what is in the air. And so we've done a lot of outreach programs trying to get students just like you to get more interested about the air we breathe. So look out for, when we stop being remote, look out for more of these programs in the future. And I think that's all I'm going to say about myself.
Yes, breathing is a good thing.
Yes, it's very important.
At this point, a lot of the students are going to be talking about what they do in the lab. So we want to right now show a little clip of Jack, Sandra, and Cody actually in the Gen Lab.
Welcome to the Gen Lab. Come on in. So here in the Gen Lab, we focus on understanding how particles form in the atmosphere and what pollution does, not only to our climate, but also to human health. So the first thing I would show you is sort of the experiments that we do to understand how particles form. And this is our mini flow tube reactor. And basically what this is for us, it's a way of narrowing in a big complex, huge atmosphere in a small setting. And what we do is we inject sulfuric acid at the top of the reactor. And sulfuric acid, you can think of like acid rain. When it rains, you have high concentrations of sulfuric acid outdoors. And this sulfuric acid can form particles with different compounds like amines. So amines are emitted from like cow and animal products. So we will inject both of them into the reactor, and then we observe how these particles form in what is called a mass spectrometer. And so what a mass spectrometer does is When the particles are formed, we give them a charge, and so they're very happy to get detected by this little instrument here. And then based on how heavy some of the particles are, so what we call the mass to charge ratio, they can either accelerate in a shorter amount of time or in a longer amount of time to the back of the instrument where the detector is. And so every time a charge hits the detector, it's counted. And then we use a computer over here to calculate the concentrations of each of those particles based on how many particles hit the end of the detector. And here we just have the electronics, so different electronics for controlling this. We also have here mass flow controllers, and these help us control how much of the sulfuric acid or nitrogen or amines that we want to inject into the reactor.
So as Sandra was saying, we are really trying to understand how pollution is formed in the atmosphere. So over here we're looking at specific compounds like amines, which can come from pollution from cows or other industrial processes from human activity. So here we're trying to understand how many of these compounds are in our system. So we use nitrogen gas to carry these compounds into this vial. And from here, our probe can measure the concentration of the pollutants that we're introducing, which can then be translated into our flow tube experiments.
So this is the burn chamber. Oh, sorry. My name's Cody Jen, and I am part of the Jen group. And we're entered into a different room, but in here we do smoke experiments. We're trying to understand how smoke from wildfires can hurt people when they breathe it in. And so obviously we don't want to set a wildfire in the lab. That'd be very difficult and very dangerous. So we have something called a burn chamber, which is here. And it's basically a bigger version of a fireplace. And depending on what we're studying, sometimes we look at wood pellets that people use to keep their houses warm. Or sometimes we put tiny little trees, like tiny Christmas trees or something, in here and we light them on fire. And then the smoke travels up the stack. And then we have all these instruments around it that take in the smoke, and we can measure all the different chemical properties of the smoke. And so this is a really neat setup. It lets us basically recreate fires in a controlled way, so we're not burning the whole building down, inside a chamber. Yeah, so the 3 clips you saw were of our lab space, and at Carnegie Mellon, our lab space is part of the Center for Atmospheric Particle Studies, which is 9 professors that all work together to solve air pollution and climate problems. And we primarily took those videos partially in my lab and partially in the Center for Atmospheric Particle Studies lab. And you can tell the lab it looks kind of messy on the face of it. You see tubes going everywhere and wires going everywhere. And that's kind of like the mad scientist routine. That's how I consider it. But we have very, very sophisticated instruments behind some of those boxes, behind some of those tubes. And these instruments can detect things that our noses and our eyes cannot see. And that's why we need all these crazy powerful techniques to study all the cool chemistry that's happening in the atmosphere. And then we have some of the lower tech things in our lab, like burn chambers, which is literally kind of like a fireplace inside of our lab. And these, no wires needed. You just need something to light on fire. And so we kind of cover the whole spectrum. We can make pollution, we can measure pollution, we can do it all in our lab. And so I'll pass it on to Sandra after this, who is my most senior, most awesome grad student, no offense to everyone else. And she'll tell you a bit more about herself and her research.
Hello, everybody. I'm Sandra Fomete. I'm a 4th year PhD student in the chemical engineering department. And one of the videos that you just watched from me was walking you through some of the experiments that we do in the lab and that I do most of the time, which is studying how particles are forming in the flow reactor. So you can imagine the atmosphere is a very big, complex system, and it's very difficult to go outdoors and start measuring each individual particle and each individual compound. So what we do is we inject specific compounds that we want to study in this flow reactor that you've seen in the video. And then we use some instruments that Cody mentioned, like mass spectrometers, to measure the very, very tiny particles that you can't see and you can't touch. And so what's really cool is we get to see specific particles form that we're interested in, and sort of see how that applies to the environment. Other things that you've probably seen in the videos are like mass flow controllers and mass flow meters, and these are really interesting gadgets for us to measure how much compound and how much chemicals we're putting in the reactors. So besides just doing experiments, we also spend a lot of time analyzing data, which is a huge portion of being a co-scientist. So at the end of the day, you end up with tons of data from all these experiments that we take time, write different programs and different codes that you probably would learn about at some point, and then determine how these particles were formed and then how they apply in the environment. So with that, I will pass over to Jack to talk about himself and the video.
Hi everyone, I'm Jack Johnson and I'm a third year chemical engineering student in the Gen Lab. And so like Sandra, I'm also interested in understanding how these particles are forming in our flow tubes. And for the setup that I was looking at, we're trying to understand the quantity of these compounds that we're injecting into these flow tubes, so we can make sure that we're within a range that is sort of representative of our atmosphere. We're not injecting too much and not injecting too little. And a lot of these compounds come from agricultural processes, including animals, as well as even cow farts and cow burps can contribute to a lot of these particle growths. And since humans are eating all of these animals, we're also creating a lot of these extra particles. And so for that setup, we have, we're doing acid-base reactions, and the compounds will slowly react together until the pH has reached 0, and we can track this pH over time. And this helps us understand that we're representing our system well.
Jack, I don't know if you mentioned this or not. What's the name of the machine you were on?
So it's a pH probe.
Okay. Is PERM then an acronym?
So for the permeation tube.
Okay.
Okay, yeah.
Okay.
So those are two separate things.
I just knew I wasn't going in there to get my hair done.
Oh, right. For sure.
And audience, I don't know if you had taken any classes. Jack and Sandra both served as teaching assistants when Cody did some of her classes. So we want to thank them for doing outreach in person too. Next, can we have Deanna?
Hi everyone, my name is Deanna Badger and I'm new to the lab. So I'm a first year chemical engineering PhD student. So when I finally get to start doing research, which will be probably next month, I'm going to be looking at how wildfire smoke may harm lung cells. So I'm not only going to be working with the Gen Lab, but I'm going to be working with another lab in the bioengineering side of things as well. So I kind of get the best of both worlds. But so far this semester, I mainly was focused on taking classes. Before I came to CMU, I got my undergraduate degree at Duke in environmental sciences. So chemical engineering is also kind of a pivot for me. And I'd be happy to talk about that more later too.
And you're a Pennsylvania person too, are you not?
Yes, I actually grew up in DuBois, Pennsylvania, which is only 2 hours away from Carnegie Mellon. So some people might be familiar with it.
And one more question, Deanna. You're studying the toxicity in the wildfire particles, right? Okay.
Yes.
Okay. That's not.
I was trying to simplify my description a little bit.
Okay. All right. And then let's hear a little bit about who's next. Dominic.
Hi, I'm Dom Casanuevo. I'm also a first year in the Gin Lab, so also new. But I'm working a little bit more in project related to Jack and Sandra, related to composition and particle formation. My research is the aiming to create a new instrument that's a little bit more portable than the one you saw in the video. And so the idea would be that this is something you can then take outside and more readily be able to take field measurements, because as I'm sure you saw from the video, it's not something that'd be easy to move. And other than that, I did my undergraduate in chemical engineering, so I a little more in line for that, but there's really all sorts of things you can do, because even atmospheric science is not directly chemical engineering.
Thank you. Thank you. Darren, how about a little bit about you?
Hi everyone, my name's Darren. For one, I'm also a first year PhD student, but in mechanical engineering. I also just realized, Cody, that all your new students have D names. Was that on purpose?
I tried to convince Wendy to change her name in it.
Darn it.
Yeah.
So yeah, as I said, I'm a first year student in mechanical engineering. So unlike the rest of the lab, I'm less focused, less interested in all the like nitty gritty chemistry stuff. Seems silly, yes. But I'm more interested in the instrumentation side, kind of like Dom was just talking about. So right now, what I've been doing is I've been working towards a new particle charging instrument called a paper spray ionizer. So the mass spectrometer, and I'm not sure if Jack and Sandra showed the mobility analyzer, but those rely on, okay, they didn't. So the mass spectrometer relies on voltage, so the electrical charge that a particle has, in order to sort it. So you first have to charge the particles before they go in. And so I'm working on a different way to charge those a little more gently, so you get more information about them.
So you're interested, your research is interested in creating, I guess, the instruments to be used.
Yes.
Okay. All right. Well, thank you all for coming. This is great. This is great. I'm glad to have you all here. So we had students send in questions for you to answer. And this first question, I'm guessing that because of remote learning now, the question is geared to present day. Like, what are you working on right now during the pandemic, I would imagine. Any takers on that?
I can start. Oh, sorry, Jack. Do you want to go? Okay.
I was just going to mention that we actually recently finished up a project that was related to the coronavirus, because there's a lot of interest in how coronavirus is transferred on some of these aerosol particles. So me and another student in our lab were looking at actually placing plastic boxes over patients' heads that potentially had coronavirus. And the hope is that the box would help trap all of those potentially harmful particles inside, while various medical workers and doctors can either perform operations on the patient or be able to work near the patient without risk of transmitting COVID-19.
Cool stuff.
Yeah, it's an interesting project.
Yeah, it was a neat project because it was also partnered with Allegheny Health Network. So quite a few hospitals from H and N in the near Carnegie Mellon, around Pennsylvania as well. And they built a whole bunch of these boxes with a local company called McGee Plastics. And McGee Plastics actually typically makes plastic parts for airplanes, but lost a lot of business during the COVID outbreak. And so they switched to manufacturing these boxes, which really helped keep a lot of their workers employed. But also the hospitals, I mean, deployed a lot of these, made the doctors feel a lot more comfortable being around patients in the operating room. It got our students back in the lab during shutdown, which was always really good. And it was just a really nice project to help the community with. So it actually went into our local hospitals to help. So it was nice. And the doctors are so much fun to work with. They're great.
Yeah.
Yeah, I guess I can go next. Yeah, so one of the recent projects that we've also been working on is studying a class of compounds called alkylamines. And these compounds are used in everyday products. So like body lotions, hand sanitizers, and a whole variety of daily products you could think of. And so we've been trying to understand how these compounds, when they end up in the atmosphere from us just using it, how they react with other compounds like sulfuric acid to form particles. And so again, the flow tube that I showed, the reactor, we inject these different compounds, we study how the particles are forming. In addition to the mass spec, we also connect what is called a CPC, or a condensation particle counter, and that just helps us count how many particles are formed from the reactions.
So the hand lotion that I use to keep my hands moist, is that a potential contaminant?
So it probably has this class of compounds. So the reason these compounds are used a lot in these daily products is because they're used as surfactants. So they actually help give you that slippery texture and also like mix different things that wouldn't otherwise mix. Yeah, so they're probably emitted into the atmosphere.
Thank you, Sandra. Dom, what are you working on right now?
So this past few months, I've mostly just been taking classes online, but I'll be starting going into the lab in January, where the first thing I'm going to learn is how to fix things, because the instruments are very sensitive and break. And so the first thing is, when they break, what can you do? And so that way I'll be prepared for when it does happen. So that's really the next thing is, getting into the instrument, figuring out how it works and what to do if, certain parts stop working, how to figure that out and how to fix it.
Cool, an engineer. Deanna, how about you? What are you currently working on?
Similar to Dom, I spent the last 3 or 4 months mostly on my classes, but my goal number one when I start in the lab in January is going to be to build an incubation chamber, which is basically going to be a box that hopefully will keep my lung cells alive, but also allow me to expose them to wildfire smoke that we generate in that burn chamber that Cody mentioned previously. That's basically like a little furnace where wood is going to be combusted to simulate a wildfire.
Nice, nice. Darren, what are you currently working on?
So I've been doing Zoom classes like Dom and Deanna, but I luckily have had a chance to get into the lab, so I have already started breaking instruments and getting a chance to learn how to troubleshoot and fix them. So it's been fun.
I can tell by Cody's reaction that you have broken some yourself.
Only a little bit, and I usually fix them.
What a fun group. You break it, I fix it. Okay, this next question, submitted by Dave L. Who is your role model? An interesting question. Dom, let's start with you this time. Who is your role model?
So I would say I have two, one science related and one not. First, I'll start with the non-science related, which is a little corny. That would definitely be my brother, because he managed to find like a way to fit his interests, which were political science and photography. So two completely different subjects, but he found a way to combine them in works like filming things related to law. And so like that sort of encouraged me to go like find a way to relate all my interests and find a path for that, which I did in atmospheric science. And in terms of science role models, I would say that a lot of like the early 20th century like chemists and physicists just did some really cool experiments with like technology that I had 100 years ago. So I think probably the most well-known is Ernest Rutherford, who figured out like there's a nucleus, or there's something in the middle of an atom. And just like the experiments they did were really simple, but also just really cool, and figured out such amazing information.
Cool. Darren, how about you? Who's your role model?
So I'm lazy. I only have one, but I would say it's probably Kenji Lopez. He's a chef and a food writer, and something that I really admire that he does is he brings a scientific method into cooking. So a lot of what you hear in what you read in recipes and books, it's all information that's just been passed down chef to chef to chef to chef. But who knows if that's actually the best way to cook something? So he looks into stuff like, hey, what's the best way to scramble eggs? What's the best way to boil eggs? Like, do you actually need to boil water before you put the pasta in? Answer is no. It just makes the timing a little easier. And I guess I really just admire how he like looks at everything kind of like a scientist trying to figure out what exactly is the best way to do this by, you know, kind of doing experiments, trying one thing, and if it doesn't work, moving on and trying another. And I think and most importantly, I really like eating, so.
I was going to ask if you like cooking.
I do like cooking.
Okay.
Yes, I like cooking and having friends over. Of course, it's kind of been hard with the pandemic. It's just been me, so I've been eating a lot. Let's put it that way.
Are you taking anything that you learned from him and applying it to your cooking?
Not yet. I've been thinking. So one of the things he's been writing a lot about lately is how to get a nice breath of the wok flavor in fried rice. So when you make fried rice, traditionally you do it over a gas stove, and when you flip that wok, there's the little oil particles that get thrown up. They'll burn slightly from the gas stove. However, I have this like really, really small electric stove with no vent on top, so doing that's not really possible. But apparently what you can do is you can get a little burner, kind of like what you see in movies when people are making creme brulees and burning the top, and you just go over a little bit and you get that nice little like not burnt, but like deeper flavor.
Charred flavor.
Charred, yes, that's the right word.
Now he's making us all hungry. Deanna, how about you? Who's your role model?
So my role model isn't a single person. It's sort of a conglomerate or hybrid of women in science and engineering who kind of helped pave the way for me to have the chance to now study science and engineering. And on a more personal level, when I was a kid, I always really looked up to my grandmother because she always listened, even though I was a little kid. She took the time to listen to what I had to say, and she gave me great advice, and was just a really generous and supportive and caring person. And she encouraged me to pursue my interests in science too, even though she didn't have a lot of knowledge on the subject. So I think that kind of helped give me the confidence to study hard in school and to stick to science even when things got hard in my classes.
Great answer. Grandparents are good for that stuff. Sandra, let's move over to you. Do you have a role model?
Yes, I do.
Good.
Yeah, my role model is my dad. So I'm one of 4 girls to my parents, and I'm the last one. And so I might have mentioned this before, but I'm from Cameroon, and so Cameroon is a very patriarchal society where you have gender roles as to, you know, what a girl does, what a boy does, what sort of career like a woman goes into. And I really admired my dad because he didn't ever lock us into that expectation of what a woman should do and not do, because he only had girls anyway, so he could just say, you know, this is what you should or shouldn't do. And so he really exposed us to all possibilities of what we could do as kids. And I really admired him too, because he was the first engineer I always knew. And it was really cool to see the work that he did. So he's an environmental and forestry engineer, and works on a lot of conservation projects in Cameroon and around like sub-Saharan Africa. So I just really admire his dedication, his work ethic, his appreciation of, you know, women in society, and just the work that he's done also in giving back to a lot of communities in Cameroon.
Very nice. Very nice. Great dad. Jack, how about you? Who is your role model?
So I think I'm going to have to follow Dom a little bit, that I kind of have two, on more of like the sciencey side, and why I got interested in science originally is probably actually also kind of 2 people, but Neil deGrasse Tyson, and then Bill Nye the Science Guy. And just what I really appreciated about both these people is their ability to make science available to everyone and communicate that to a wide audience, which is arguably more important than the science itself, and just being able to get those messages out. And then on the personal side, I'd probably say my grandfather. He is 88 years old and will probably still beat me down the mountain when we go skiing here in a few months. And I've just always really admired his drive to like pursue his hobbies and his passions. And I swear that guy will be skiing at 100. So.
Great answer. Great answer. Should we do a drum roll? Cody, do you want to answer this one as well?
Sure, I'm more than happy to answer this. So I'm not going to say this just so my grad students like me more, but my role model has been all the academic advisors I've had in the past. I had a great research mentor when I was an undergrad, Faye McNeil at Columbia University, and she was the first professor in the department, first female professor in the department to get tenure. She had this like great attitude on research and how she approached learning, and she just empowered all of us to like just build stuff and do cool experiments. And then she actually put me in touch with my PhD advisor, who is he just retired, but he is someone I want to like become. He is like the nicest, most ethical, most down to earth, the smartest person I could ever imagine. And you talk to anyone in our field, they're always like, oh yeah, Pete McMurray is really sad he retired. And so that is someone I hope to become. And I try every day when I work with my students to think, okay, take a step back. What would Pete do? And just like Jack was talking about his grandfather, Pete is like 75 or something now. And he can still bike faster than me. He can still like swim faster than me. And he always joked around that anyone who could like sail a boat faster or bike faster or swim faster than him had to leave his group because no one could ever do that. So he was just like one of those really fun people to be around. And then my postdoc advisor was a really great role model in that he spent a lot of time being very clear, like you need to have a work-life balance. Like it's really easy for all of us here. You listen to all of us talk about what we've been doing now. It's easy for us to just think all about work. And what was great about my postdoc advisor is he had so many other hobbies. He was really into growing fruit. So he was really into like horticulture and all these different fruit trees. And I tried to take some of his fruit. He did not appreciate that. And he made wine. So it's just nice knowing there's people out there who are incredibly great scientists, super smart, work really hard, but are also like normal people and have all these like fun hobbies that you don't have to be a person locked up in an office or in a lab. There's like so much out there in the world to see and still do cool science. So those are my role models. But again, not to pressure my grad students into loving me more.
Yeah, your grade does not depend upon how you answer, and that's why I saved her for last. All right, our third question comes from Dan R. Dan, knowing now that where your past ended up, Dan R. wants to know, what was your favorite subject when you were in school? And I'm assuming either elementary or high school. Let's start in the middle this time. Deanna, what was your favorite?
My favorite subject in school was always chemistry, mainly because I had an outstanding high school teacher. And what was really great is that I had a chance to be in his class for 2 years. So he got to know all of his students really well during that time. And we did a lot of hands-on laboratory experiments in his class. And I think that made all of the concepts he was teaching a lot more tangible rather than abstract. So his class actually prepared me when I went to college as well to take chemistry courses, and I was majoring in environmental sciences, but since I came in with this passion for chemistry as well, I took a lot of chemistry courses, and that in kind of a roundabout way eventually led me to pursue chemical engineering in graduate school. So it all started with that teacher I had in high school, and I actually still keep in touch with him. And similar to me, he really likes the outdoors. So he has an outdoor group where he meets up with his former students and goes on hikes around the area. And I think that's really great too. So he genuinely cares about all of his students and still checks in on us and likes to see like where we are now. So I really appreciate that.
Very nice, very nice. Sandra, how about you? What was your favorite subject when you were in school?
So similar to Deanna, my favorite subject was actually chemistry too. And the reason was because my chemistry teacher was the only female science teacher I had through like primary, secondary school, and high school. And so it was really just interesting I felt like I connected with her as a teacher, and also she was a really good teacher. But also it was really interesting because it just seemed like everything was made of chemicals and chemistry was all around us. So I just really enjoyed just learning how everything was made and like how all these different chemicals made stuff, and how eventually you could like scale up this sort of mini reactions into like, actual useful things that we use on a daily basis.
Yep. Jack, how about you? What was your favorite subject when you were in school?
I think for me, I really liked Spanish class and just kind of learning a foreign language. It was a nice break from some of these more technical classes and stuff. So yeah, it was a fun class.
Cool. Cody, how about you? When you were in school, what was your favorite subject?
Kind of along the same lines as Jack. So my favorite classes were all the literature classes. So like in high school it was like British literature, American literature, or world literature. And half of it was I really enjoyed reading books because I was trying to impress this boy that was not really in my high school, in a neighboring place, but loved reading books to impress this guy. But I actually just in general love reading books. You can tell I have a lot of books, and it, like what Jack said, it was a nice break from all the science and math classes, which I also really enjoyed, obviously because I'm now doing all of it. But it's nice reading a book because I don't know, it's just the world just seems so much more peaceful in a book compared to all the chaos of doing homework and tests and things like that. So I love reading.
Cool. Tom, how about you? What was your favorite subject when you were in school?
I would say in elementary and middle school, my favorite subjects was definitely math. I just really liked the one had a good math teacher, but also the whole problem solving side of it. But it's definitely changed over time.
Cool. Math teacher. Darren, how about you? What was your favorite subject when you were in school?
I'd probably have to say art. I actually ended up doing an art and design minor when I was in college, but I don't know. I guess for one, I can't draw, so not like that kind of art. More enjoyed sculpture and photography. So something about being able to create something from nothing, and I guess more on the photography side, just like kind of just stop the world for a moment, capture something that's nice and serene. I don't know, something about the whole creative process. I tend to get lost in it a little bit, and I'm one of those kind of people that my mind just goes 1,000 miles a minute all the time. And so it's really nice to be able to kind of just get lost in something else for a while.
So when you break something in the lab, are you more concerned with how it looks artistically or how it works when you're done putting it back together?
A little bit of both. A little bit of both.
Hopefully it's accurate, right, Cody?
Right. But if it doesn't look nice, who's gonna use it?
He did a great job, like making this spring out of wire instead of buying a spring. It was very artistic. I will give you that, Darren.
The lab looks so cluttered, though. I don't, it's like not
It's
very.
a work of art. You just gotta embrace it.
Work of art.
I get-
Need to add some
The
color.
creative process.
We color coded the tubing. I mean, what?
What a fun group. This last question, it was submitted by Zoe V. And I think it's very, and hopefully you had time to think about it. It's a very good question. A lot of you hinted to, past experiences, but what Zoe wants to know is what interested you to do what you do today? Like we all talked about, you answered the question, what we're doing now, but what interested you to do what you're currently doing today? Cody, let's start with you this time.
So it's interesting. It's a great question. So the field we sit in, like I come from an engineering background, and the field we sit in traditionally does not fall in engineering. So it's actually quite difficult to know this field even exists. And I like to think like when I was in elementary school, middle school, high school, never would I have thought I was going to become an atmospheric scientist or an aerosol scientist or an air pollution, but like that never crossed my mind. I wanted to be a plumber. Really wanted to be a plumber. And so when I went to college, there was a huge push to get undergrads to do research in labs. And the only professor who responded to my email to like, can I work in your lab, was someone doing aerosol science or atmospheric chemistry. And so I kind of fell into this. It wasn't something I wanted to do, but it was, once I was in it, it just became so much fun. The field is great. The societal problems are there and need to be solved, obviously. And it is something that I wish I knew before was an actual research field, like to go out there and measure air pollution and understand its health impacts. But it's something traditionally engineers do not consider engineering. We think of like building things, or from chemical engineering, we think of petroleum industry, like how do we design better oil wells or things like that, or pharmaceuticals. And so this is a great field to get interested in, but there's just not that many of us trying to study what is air pollution. So I came from it by accident, and then I've just stayed in it ever since.
Interesting. Don, how about you?
Mine was I essentially kept trying things until I found bits and pieces of what I liked. Like I found I liked chemistry, I liked physics, I liked the environmental applications of for research. And so I really like tried things, tried to figure out what I liked from each one. So prior to coming here, the research worked more with circuits, but which I thought the chemistry and physics was interesting, but I wanted something with more environmental applications. And somehow I sort of stumbled across atmospheric science and particles science in particular, and it really fit everything that I was looking for. So I would say the most important part though to getting here was just to like keep trying things and figuring out what you like from it, and then keep looking for something that really fits that.
Yeah, it's finding your passion, I guess.
It was not an easy or quick path to get here.
Yeah,
but I mean it was fun. I learned a lot along the way.
Thank you. Darren, what interested you to do what you do today?
Yeah. Well, I guess starting off from a young age, my dad was a professor, so I never really had the chance, microbiology professor. So I never had the chance to get out of STEM. I'll first say that, just because, from a young age, he'd like bring home his college level microbiology exams and make me help him like grade them, add up the totals. And he'd like make me answer the question. So one, I never really stood too much of a chance of getting out of STEM. But I do enjoy it. That's why I'm here. I think also kind of what brought me here was kind of like what Cody said. I became a mechanical engineer because I really like building things, really always liked taking things apart, seeing how they worked. But the whole time I was going through it, it never felt like anything that mechanical engineers traditionally do really clicked with me. So I went to University of Michigan. It's surrounded by the automotive industry. So I had a ton of friends go that direction and then some go into aerospace. But I never really got interested in those, never really clicked too well with me. And I actually ended up working for 3 years on designing essentially factory tooling. So kind of like how you see in all the how it's made, designing all the tooling that goes up and down to make things. And that was cool. But for me, something was always missing. I guess partly from my dad, I've always been interested in trying to find new knowledge, try to figure out things that we didn't know before. And between that, building stuff and just wanting to do something a little more interdisciplinary, that's kind of, how I found my way over to atmospheric chemistry. Long-winded answer, but.
Good answer though. Great answer.
Thanks.
Deanna, what interested you to do what you do today?
So I grew up in a really small town of Du Bois, Pennsylvania, and I really wasn't exposed to that many different careers when I was a kid. But one of the things that I always liked that was a constant was being outside. And my dad is really interested in wildlife photography, and he kind of instilled in me this sense of love for the environment. And of course, anytime you really like being outside and all of the animals in nature, you find out that humans are harming them and killing them. So I kind of knew from a young age that I wanted to do something related to the environment to try to help protect the land around me. So I didn't have a chance to take any classes that were related to the environment, like when I was in high school. So when I went to college, I decided to major in environmental sciences, mainly just based on my guesswork of what that might be. And Duke University had an 8,000 acre forest, and that's one of the reasons I wanted to go there, because I actually wanted to have a chance to be out and be in the forest, hopefully doing research there. But what ended up happening was that while I was in school, I was taking my environmental sciences courses, but I also was taking my chemistry courses, and I kind of discovered this sweet spot for me in environmental chemistry. And that's where I found out that humans were creating a lot of chemicals that did a lot of good things, but also some chemicals that were having some unintended consequences and had the potential to actually harm people who were exposed. And typically what would happen is that once a chemical was discovered to be harmful, industry would come along and like slightly change it, but the chemical was still similar enough that it could also induce harmful effects. So it was kind of this endless cycle where researchers would find out that a chemical was harmful, and then industry would like slightly change it and you would be back at square one. So that's where I was at when I was at Duke. I ended up joining my environmental chemistry professor's lab group, and we were looking at chemicals called flame retardants that, just as the name suggests, were added to products to try to prevent them from catching on fire. But it turns out that these flame retardants had the potential to harm people. They were toxic. So I think the reason I decided to go into engineering subsequently instead of just sticking with environmental chemistry is due to the kind of frustration I had that like once you found out that a chemical was harmful, you were kind of stuck. Like industry would just slightly change it, and it was hard to see like a good outcome from that. So I wanted to have more tools to try to solve some of these environmental chemistry problems. And the wildfire smoke was kind of a like natural pivot point for me, just because I'm still looking at human exposures to compounds that cause harm and trying to figure out like what they're doing in the body. And hopefully like with the engineering toolbox, in addition to the science knowledge, I have more ways to actually like solve the hard problems. But similar to what everyone else said, I don't think anybody ever has like a really linear path where what you think you want to do whenever you're a kid is exactly what you end up doing as an adult. So I think it's important to be really open-minded to trying new things and exploring, and to never stop learning.
Some great advice for our students. I was going to ask you later, do you have any advice for our students? But I think you hit the nail on the head right there. Really great. You know, you may not know what you want to be right now. What you may want to be right now doesn't even exist, probably. So like Deanna said, stick with it. You'll find it eventually. Sandra, let's go back to the question. I'm sorry, I get off track sometimes. What interested you to do what you do today?
So first of all, I decided to do engineering when I got to college because one, like I said, my dad, who's my role model, was an engineer, and so I just wanted to do engineering. But also I didn't even know that chemical engineering existed when I left Cameroon for the US. So my chemistry professor in at community college when I got here was a chemical engineer herself. And so she started exposing me to the field of chemical engineering and made me read articles and read stuff about chemical engineering. And I realized it was a thing, and it just made sense because I love chemistry, and you know, it was sort of what I thought at the time would be similar to chemistry, which chemical engineering isn't really chemistry. So I got into it in undergrad. I really enjoyed it. So when I was applying to graduate programs, again, it was very natural for me to continue doing chemical engineering because I really enjoyed my undergrad. But I thought what was also really fascinating was the fact that you didn't really get locked into one thing in chemical engineering. So it almost seemed like there was all these opportunities you could do, bioprocessing, but then chemical engineering, you have people who are doing more like computational stuff in chemical engineering. You have people who are doing like environmental stuff like we are doing now. So that's why I applied to graduate programs for chemical engineering. And then when I got into the program here at CMU, the project that I was actually really interested in was renewable energy, because I come from Cameroon. I come from a region where there's a lot of sun. And so I was really interested in doing something related to solar energy and capturing solar energy for applications in sub-Saharan Africa. So that's one of the projects that I put down, but also when Cody presented her project on organic nitrogen compound, I was like, wow, it would be really cool to work with Cody. I really enjoyed how she talked about the project, her energy, and her excitement for research. So that's how I also put Cody down, and I ended up working, ended up being in the Gen Lab and working with Cody, and it's been fun. So I would say it's not been a very linear path as well. Like I didn't know that I would do atmospheric chemistry. I didn't even know it existed, just like I didn't know chemical engineering was a thing. But it's been interesting. And I'll also say, I don't think it's, you get locked into one thing. I think the next step could still be doing renewable energy ultimately, because they're all interconnected, and it's all about finding ways to have more sustainable systems that have that don't have a net negative impact on the environment.
So you're 4 years with Cody now?
Yes.
Okay. And how many more do we have?
Hopefully 1.5 or 2 maximum.
Okay. Cody's smiling. In a nutshell, I know this is a whole dissertation you could do. Sandra, can you tell the students what the big difference is between the chemical engineering you talked about and chemistry? What's the big difference there?
So chemistry looks more at the fundamental aspects of like reactions, like how reactions happen, what compounds react, molecular structure of things. And then chemical engineering is more about scaling up those reactions. And then an added point is like, so we talk more about like kinetics. So understanding like the energy that's either emitted or needed for reaction. So like chemical engineers would say, okay, we go to a chemist and say, okay, this, we know you have this reaction, let's say for producing water, hydrogen plus oxygen to make water. And then the chemical engineer would say, how can we mass produce this water, right? How much energy do we need? Do we need to, size the pump to make this reaction happen? Do we need to supply like energy, and how would that be? So it's more on the, I won't say just instrumentation portion of things, but it's really like looking at the chemist's fundamental reactions and seeing how we can scale it up to make it more applied and like more useful.
Thank you. Thank you. I just wanted clarification so that they know chemistry and chemical engineering, those are 2 different paths you can take.
Yes.
It all depends on your interests.
Yes.
Jack, I'm sorry. And finally to you, what interested you
Yeah,
to
no
do
worries.
what you do today?
Yeah, so I think maybe to echo Sandra a little bit, the main reason I chose chemical engineering, like going into undergrad, is just the many diverse career paths that you could still go into. When I started college, I didn't really know what I wanted to do. I was still considering being like a medical doctor. I was considering being an economist, and also had a lot of interest in environmental science and trying to solve this big problem of climate change. And I had a chemistry teacher in high school who really introduced chemical engineering to me and all of these different diverse paths that it could take. Like, it's not just oil industry anymore. So going through undergrad, I kind of stuck with chemical engineering, and it turned out that I really liked it. I liked the subject. And then getting more towards like grad school and what I wanted to do, at this point, I had really decided that I did want to go into sort of an environmental path and try to help in any way I could to sort of solve this problem of climate change. And so that's kind of what made me look at Cody's group, as well as a few other groups that were doing environmental work with through this lens of chemical engineering.
Nice. Deanna is the only one that's in both labs. Okay.
Darren's actually in 2 labs too.
Yeah, I'm in 2 labs as well. But
Okay.
the other lab is also, I'm doing instrumentation in the other lab as well, so.
Okay, good to know. Well, we do have a little bit of time left, and maybe we can answer this one as a group. The question I have, most of our viewers are kindergarten through ninth grade students currently learning remotely for the most part. Is there any advice that you could give our students on anything, schooling, sticking with it, anything you want to say to our kindergarten through ninth grade students? Dom, how about you? Do you have anything? And we'll just build on what Dom says.
Yeah, I'd say like try and find like a way or like some medium of information for like science that you like. So like Jack mentioned, Bill Nye and Neil deGrasse Tyson. I remember really liking Nova, like watching Nova when I was, elementary, middle school, and just there's so many different like material, so much material out there, either on TV or on the internet that has like maybe there's science experiments you can do at home, or it's something like Nova where it's like a big TV show. So find something that you like, either reading, watching, because it is like you said, it's important to stay interested in it. You don't want it to just feel like you're just learning for class. You want it to be something that's interesting. So finding something like that that draws your attention would be my advice.
Nice.
I can add to that. I totally agree with Dom that finding a method to find something interesting is really important. And to add to that, find everything interesting. What's so great about being in school is, and I'm going to be in school for the rest of my life. What's so great is everything is fun. Like irregardless of if it's science, math related, or if I'm reading a book, or if I'm outside, like everything should be fun. And when Darren thinks he's laughing because he probably thinks this is super corny, but what makes school difficult is when you don't find it fun. And to ask yourself, why is it not fun, and how to make it fun is a way to get through school in a much more happy kind of way. And I know remote learning is not fun. Trust me, as a teacher, it's not fun. But there's so many things out there to go explore and do and see that to say this whole field, like I hate math or I hate chemistry or I hate physics, is really kind of sad, because there's so many cool things. Like Don was talking about Ernest Rutherford, and what was so cool about his experiment was he hammered gold until it was a single atom thick, basically. And so if you don't really find like nucleuses of atoms cool, maybe you find that hammering gold foil over and over and over again until it's super thin is really cool. And maybe you get into instrumentation design. So there's so many interesting aspects out there to go and learn and absorb that I just cannot fathom not going through life and just always being amused and happy. That's my 2 cents. Sorry.
Nice.
I was going to say, I wasn't laughing because I thought that was cheesy. I was more laughing because, at least for me, after you start working, you kind of realize that you get paid at a 9 to 5 to do what you're good at, which ends up being pretty much the same thing every day. So school is fun. You really get to do new things. You get to try new things every day. And I think the one thing that I would say, kind of building on what Dom and Cody have been talking about, is, just never stop exploring. I think these days it's really, really easy to get kind of stuck in a bubble or stuck in your own comfort zone. Like, say you're on YouTube or Spotify, they recommend songs, right? But they recommend songs or videos that are similar to the ones that you like and that you've already watched. So you end up watching a lot of the same things, maybe over and over. So, try some new music, or try different. If you're reading a book, maybe pick up a different genre. You'd be surprised. I always surprise myself that I like something. I never thought I would like fluid dynamics, but here I am.
That's advice that my mom gave me once. How do you know you don't like it if you haven't even tried it? So try as much as you can.
And try it again. I did fluid dynamics in undergrad. didn't really like it and then proceeded to make fun of my friends who did enjoy it. So this one's really coming back to sting me.
Sandra.
Yeah, so just to add on what has been said, I think it's also really important to ask questions. I think what helped me all the way to here is just asking questions to people that I meet. You know, like if you meet someone who's doing a job that you're curious about, like ask what the job is like. You know, ask what got them there. Ask what what they enjoy the most about their job, about the subject. I found it to really open your mind to different perspective. And yeah, it just really helps. And I think even for us at this point, I still ask a lot of questions, like what would I do next year, what would I do in 5 years from now? I don't know the answer, and it really just gives me a lot of perspective to different possibilities that are out there.
Good advice.
Yeah, I would say that's really important ones, just asking questions, keeping curiosity.
Well, I think that was some really great advice for our Guelph Outreach students. At this point, it looks like we're almost out of time. So I want to thank Cody, Dom, Darren, Deanna, Sandra, and Jack for spending this time with us. I guess I should thank CAPS as well, since you're all part of CAPS. I'd like to thank the Leonard Gelfand Center, who makes the show possible. I'd like to thank Lisa, Dave, Dan, and Zoe for submitting their questions. And I'd like to thank you for watching the show and continuing to support the Gelfand Outreach program. Stay tuned for our next episode. Bye.